that will be second x radius of second circle, which can be drawn from outside circle. This is x circle out of the circle line, out of the circle triangle, x circle of the triangle. Okay, triangle ABC will have x circle, which is outside this triangle, which can be drawn like this. In that situation, it will be B point. This will be, let's take A and C point in that situation, and the radii will be R2. This is I2 suppose, this is R2 radius. All the three radius R2, radii R2, will be same. In that situation, this is R2 radius, X radius. So three kinds of X radius, circles can be drawn to the triangle ABC from external side, from external point. They are the X circles. Okay, so these are the X radii. Now let me talk about chapter 1. So this is all about question number 4. Question number 4 we have talked about. Okay, X center. What is X center? What is X radii? Okay, and what is orthocenter? And centroid. What is in center, in circle? All those points I have talked about. Let me talk about question number 5. Some facts regarding these geometric centers. Geometric centers of a triangle. There are certain facts. Let me talk about those facts. Question number 5. What are the facts? Now, facts about geometric centers. About geometric centers. Geometric centers are, again, first let me take circumcenter or circumcenter. Second point or B point here is in center. In center. For third point. So third point here. Then we talk about centroid. Fourth point, let me talk about centroid. Okay, we have taken. Then okay, centroid, in center, circumcenter, and orthocenter. Fourth is, let me take orthocenter. And fifth, which is excenters. Excenters also. Because excenters are always lying outside the triangle. That is not a matter of discussion. This is the fifth point here, excenters. The facts regarding what are the important facts about geometric centers of a triangle. Let me talk about them. So, facts about this. Okay, let me find a solution. Solution. What are the facts here? First facts. Okay, let me first talk about circumcenter. Circumcenter of an acute angle triangle. Of an acute angled triangle will lie inside the acute angle triangle, inside the triangle. Let me take this triangle ABC. Okay, circumcenter of an acute angle triangle. Circumcenter of an acute angle triangle will always lie inside the acute angle triangle, inside the triangle ABC or acute angle triangle. This is acute angle triangle. ABC is acute angle triangle. So this will lie inside. Second point, circumcenter. We talk about circumcenter first. Circumcenter of a right angle triangle. Okay. Of a right angled triangle. Let me take ABC. Will lie on the hypotenuse. Will lie on the hypotenuse of the right angle triangle, and it will be the midpoint of the hypotenuse. And it will be the midpoint of the hypotenuse. Try to understand the point. And third point we talk about. This is circumcenter we are talking about. Now circumcenter of an obtuse angle triangle, will lie outside the triangle, outside the obtuse angle triangle, outside the obtuse angle triangle, obtuse angled triangle. Okay, for example, if I take, this is an obtuse angle triangle. Okay, so if I draw perpendicular bisectors of any these two sides, so this perpendicular bisector will be here, perpendicular bisector of this also, like this one, it will lie here, perpendicular bisector of this side also. Okay, this may be meet here, that will pass through all the three angles. Or if I take the radius of circumcenter, so this is distance, all these distance will be equal, then circular will be passing through this. Okay, so that's sorry, not here, I'm sorry. So this will lie here, somewhere here, perpendicular bisector this, perpendicular bisector of this side also. Now from distance from this and to this point, that will be the radius. Okay, it will lie outside the side opposite to the obtuse angle. Okay, so lie outside the side opposite to the obtuse angle. So obtuse angle is this, opposite to this obtuse angle side opposite to obtuse angle, this circumcenter will lie. Okay, circumcenter of an obtuse angle triangle will lie outside the obtuse angle triangle. Okay, so that is the some facts regarding these triangles, acute angle triangle, obtuse angle triangle. This okay about circumcenter. Similarly, the fourth point about incenter. We talk about incenter. The incenter will lie always inside the triangle. Why? Because it has touched all the three sides. So it will lie in center, is not a matter of discussion. Because in center will lie inside the triangle. In center because it has touched all the three sides inside the triangle. So name is inside, in center. It will lie inside the. About in center, it will not any fact. This will lie inside the triangle. It is obtuse angle triangle or any triangle. It will lie inside the triangle because it is in center. That is what the point. What about orthocenter? Let me talk about now. Circumcenter we have talked about. Now excenters are always lying outside. That doesn't matter. Now in center will lie inside this. Okay. Triangle, any triangle. Yeah. Now we point orthocenter. Orthocenter will lie inside the acute angle triangle. This is acute angle triangle. Okay. Sixth one, orthocenter will lie on the hypotenuse. No, not on the hypotenuse, just opposite to the hypotenuse. On the vertex, opposite opposite the right angle, opposite, sorry, opposite the hypotenuse, on the vertex opposite the hypotenuse, at which the right angle is formed, the right angle is formed. What does it mean? That means the center at which right angle is formed, that point is the orthocenter. Orthocenter is the point on which right angle is formed. In a right angle triangle, for example, let me take this is right angle. Now this is the orthocenter here. Why? Because perpendicular bisector of this side I have drawn, or perpendicular I have drawn from this side. Okay, all the vertices. This vertex is right angle. This is right angle, and then from third side also we have got it perpendicular to the third side. This point is the orthocenter intersection ABC. Here B is, so this is hypotenuse opposite the right angle, opposite hypotenuse. The right angle we have formed is the orthocenter. This B is the orthocenter in case of right angle triangle. Okay, this is about orthocenter. Now, in case of opposite angle triangle, orthocenter will lie outside the opposite angle triangle. That is the, let me take now sixth point. Fifth fact. I think 5 points we have discussed in the sixth point. The orthocenter of an obtuse angle triangle, triangle will lie outside the triangle, okay, or outside the side opposite to the obtuse angle, outside the triangle, outside the side opposite to the right angle, opposite to the obtuse angle, Okay, the obtuse angle is formed. For example, this is obtuse angle triangle. If I draw perpendiculars from these points, this is perpendicular to this side. From this point, perpendicular I have drawn. Okay, suppose perpendicular to other side. Okay, so this is the perpendicular from this side. This is the perpendicular. This point and to this side also. I'm sorry. From vertices we are drawing perpendicular to this side with the perpendicular. From these three sides to other sides we can draw perpendiculars. Okay, so those perpendiculars will be, for example, at this side if I draw perpendicular, then this is the perpendicular here. Okay, so then perpendicular from this point we draw perpendicular. Okay, and then from the third point this perpendicular we draw to other side. Okay, so this is, sorry, perpendicular if I draw this point will be here. Perpendicular because this side is here, this increased side. If I draw perpendicular from the three sides, also center is lying outside this triangle. But perpendicular is drawn to this side. Okay, because perpendicular drawn to opposite sides from the vertices. So opposite side, this point will be drawn like this here, and from this point we are drawing perpendicular to the other side, this one. So the perpendicular is going to this side. I mean not outside the opposite side or opposite angle triangle. Okay, so this is outside the opposite angle triangle. That is the orthocenter. Now let me talk about other points. Seventh point, that orthocenter, let me take in an isosceles triangle. In an isosceles triangle, isosceles triangle, isosceles triangle, the isosceles triangle is two equal-sided triangle. If these two sides are equal, if we talk median angle bisector, and the median here, it will meet at the midpoint. This D is the midpoint. So B and this is C, this is A point. Okay, so this centroid will lie on this median. So in an isosceles triangle, centroid, okay, the circumcenter, the incenter, and the orthocenter, all will lie on the median, which is the angle bisector from E. Okay, median of the side, suppose D is the midpoint here, because if we draw perpendicular or angle bisector from A angle, then it will meet at the midpoint of BC. Okay, now the median, on the median. So all these four, the centroid, the circumcenter, the incenter, and the orthocenter, all these four will lie on the median. Okay, orthocenter is, let me take G is the centroid here, G is the centroid, 2:1. Okay, this is also circumcenter, or maybe circumcenter here, where it is the distance AG equal to BG equal to CG, circumcenter. Now G may be coinciding in this case, then also center, perpendicular drawn from this point, that will also lie on this point. It may be coinciding, but it is lying on the median here. Perpendicular drawn, perpendicular bisectors, if I draw, this is the midpoint. Okay, they are meeting at this point in mid. So it may be G. In that situation, it is incenter or incenter as well as circumcenter. Orthocenter, it may be orthocenter. Also, all these are lying on the, all these four are lying on the median. Okay, they may coincide or may not coincide, because if this side is smaller, this side is bigger. That situation, median may be, but median will have all these four. So in an isosceles triangle, the centroid, in an isosceles triangle, the centroid, the circumcenter, incenter, and the orthocenter all will lie on the median. Okay, median or angle bisector, which is angle bisector, this bisector of the side here, angle bisector from A or any vertex to opposite side. In this case, A to BC. AD is perpendicular, maybe angle bisector is all lining, or center will lie on this point. So this is the midpoint here, D. It is median, and 2:1 they should divide in circumcenter, incenter, orthocenter, as well as centroid. All four will lie on this median. They are not coinciding, because in case of equilateral triangle, they will have the point will coincide. That will be everything. Centroid, circumcenter, incenter, and orthocenter. All the four will be there, will lie on a single point in case of equilateral triangle. But in case of isosceles triangle, they are lying on the median. This is one of the facts here. Okay. Now let me talk about eighth point. Eighth fact. Eighth point here, fact number 8. Now in an equilateral triangle, this is equilateral triangle. Let me take ABC. Circumcenter, the incenter, the incenter, the orthocenter, and centroid, and the centroid. All the four will be the same, lying on the perpendicular bisector, the median, everything lying on the median, perpendicular bisector. They are the same thing. Perpendicular bisectors of the sides, all are same thing, because this is equilateral triangle. Let me take. This is equilateral triangle. Each angle is 60 degrees in this case. Okay, so if I go perpendicular, this is median also. Perpendicular, this is also median. This is also median. Perpendicular, these are perpendiculars also. Because all sides, this is A side, suppose this is A side, this is A side. It will be A by 2, A by 2, A by 2, A by 2. And this is distance, this is distance, this in center. If we draw in circle, then it is the A radius. And this is capital R here. So this center I that we take. Or O, it is orthocenter as well as circumcenter as well as orthocenter, centroid, everything is 2:1 ratio. It is dividing. This is median also 2:1. This is 1 here, this is 1 here. Okay, so in this situation, now what is the value of this incenter? I mean, the length of the incenter. Because in case of equilateral triangle, let me take this is A, B, C. So all are lying on the same point. Now in this situation, let me take what is value of R here. With the height AD, this is the altitude also. The altitude or height of the equilateral triangle ABC in this case is AD. In this case we have taken this is okay, we can find the altitude, I mean the height AD in this case we have taken, or we can take BE also, this is altitude, CF is also the altitude. If I take this as the base, this as the base, here I am taking BC as the base, then AD is the altitude or height. Then altitude height will be what? Then AD will be, let me take, then AD square if I find equal to BD square. Okay, sorry, this is AB square because right angle triangle. AB square minus BD square. Like Pythagoras theorem, we know that this is right angle triangle. In right angle triangle ABD, we have AD square, the height we have to find. This is AB square minus BD square, because from hypotenuse square, by square of the other side is subtracted, then the square of the required side is calculated, then the square root of that we can calculate. In this case, what is AB square? AB square is A square minus BD is half of A whole square. It is nothing but 4A square minus A square upon 4A square. It will be 3A square upon 4. Therefore, AD is nothing but the square root of this. This is A root 3 upon 2. This is the height. Height is A root 3 upon 2. Okay. This is height here, AD. AD is equal to, that is A root 3 upon 2. This is height. If I have to find out radius R in center radius, therefore This is in radius or in circle radius. In circle radius of the in circle. Small r is equal to, this is 1, this is 2 ratio. Bring 1 by 3 of the height AD. 1.3 of AD by 1.3. For sum of the ratio, this is 2:1 ratio. 2 plus 1 is 3 in the denominator. Numerator we will have 1/3 of this height. This is 2 by 3. And capital R radius, that means circum radius will be capital R. Let me calculate these. So in this equilateral triangle I am calculating in radius or in circle radius. This is in circle radius. This is small r is equal to 1.3 into AD. AD is a√3 upon 2. This is nothing but a√3 upon 2 into 3. That means this is a upon 2√3. For this 3 is this 3 divided by 3. 3 means √3 into √3. So this 1√3 is cancelled out. So √3 in the denominator is obtained. This is small r. And this is twice here. And this O point that we take is OA. OA and OA is equal to capital R. This is the radius of the circumcircle. This is radius of the circumcircle. This radius will be 2 by 3 for this ratio. Median always or this in center or centroid. Always divide the median into 2:1 ratio. It's centroid also. Okay, so G centroid is this. This is equal to 2 by 3. 2 by 3. Because 2 by 3. 2 upon sum of the ratio will be 1 plus 2. The denominator 2 by 3 of a√3 upon 2. So 2 to cancel out. This is a upon √3. This is a upon 2√3. Okay, so radius is, this is OA capital radius. Okay, circum radius here. Circum radius and this radius. Now if I have to find out what is the areas of these two, in this situation, the values of the areas will be, okay, what are the areas here in this case? So, okay, so areas can be calculated from this. R square, IR square. R square is A square upon 4 into 3. 4 into 3 is 12. A square upon 12. Pi into A square upon 12. This value is area of the circumcircle, in circle. And area of the circumcircle will be capital R square, that means a√3 into pi. Okay, pi r square, that is pi r square. So this pi into a upon √3, that means pi a square upon 3 only. Okay, that is pi a square upon 12. This is here, pi r square. So this is how radius can be calculated. So this is what about some facts regarding circumcircle in case of equilateral triangle, isosceles triangle we have talked about. Now, all these facts in the question number 5 we have talked about. Okay, so in center, circumcenter, orthocenter, then all these in center. And in case of excenters, let me now clean this. Question number 5 we have completed. Let me talk about question number 6. Question number 5 are completed. Now question number 6, what is here? Question number 6 says, before that let me clean this. Okay, now question number 6 says, let's say, what are the basics of similarity of triangles? Let me now talk about how the triangles are similar. Two triangles are similar when, or the condition for them, and how similarity is defined. So these are the facts asked in the competitions. Mostly questions based on similarity of triangles, okay, congruency of triangles, etc. That is being asked in the examinations, competitive examinations. That's why I'm taking all these facts out. After that, I'll take questions based on areas, perimeters, everything, whatever. I'm taking this in detail, so please go through all these lectures from hand so that you can get complete information regarding all this. Whatever questions arise, then also I'll talk about in the hidden facts which are left or which are still left. Okay, let me take question number 6 here. Question 6 says, what are the basics of similarity of triangles? So basics of similarity of triangles. Similarity of triangles. This is triangles here. Basics of triangles. What are the? Okay, this is not question form. Let me take simply basics. So, what are the basics of similarity of triangles? No, triangles are similar. Let me take solution. Now, two triangles are similar. Let me take. This is the smaller triangle, and this is the bigger triangle. Okay, this is ABC triangle, and this is PQ. Let me take R. Now, these two triangles are similar if their corresponding angles are equal. Okay, in case of similarity, the triangles are looking, they have the similar shapes, but they are not equivalent. Their sides are not equal. If sides are equal, then it will become equilateral triangle, or sorry, equivalent triangles, congruent triangles. Congruent triangles or congruency of triangles is when in all aspects the two triangles are same, exact. Okay, then is congruent triangles. But in case of similar triangles, the shapes are similar, but they are not equivalent. The sides are different, but their sides are in proportion. Sides have some proportion, same ratio. Corresponding sides are in the same ratio. Let me write here what is similarity. Similarity of triangles. Okay, triangle, let me take triangle ABC